Hi, hello. This is Ting, and today we're gonna talk about the LeetCode question 34. Find the first and last position of an element in solid array. So this is like really typical binary search question. so yeah, the most easy way, if the question is not asking about the runtime complexity, must be in order of log n, because when we see the log n, it have to be like binary search. So just keep in mind. So if it's not asking about log n, so the most easy way is just go for loop, right? So when you first find the target, so it's the first position, right? And then you just keep going. When you find the answer, just keep going until you found the number which is not equal to target. The one before is the last position, right? So, let's go through before I start coding. Like let's go through like an example, like how to approach this question. So given by giving an example, I given this example like 5. I have a 10. Okay, so the target is 8. So what we're gonna do the binary search, right? So I don't know, so for the binary search, so that there's like kind of like 3 format to write, but I just picking the whatever comfortable one, the most comfortable one you want to try to write. I personally recommend like you just when you choose the one format to write the binary search, just go this format. Just don't change it back forward because it's just like easy to mess up. So I like to use like the while rule, right? I like to use this one like left plus 1 smaller than right. So but this at the end I need to check after the while rule. I need to check like left and then right. Yeah, but this is the way I like to go, but it really doesn't matter. It depends on you guys, right? So it's int mid equal left plus so why you write this left plus the right subject left? This because you to avoid this the overflow. What do you mean by this like overflow? Because sometimes if you write the right plus left and divide by 2, right? If if question have constraint like if right it's very big numbers, right? If right is very big numbers and plus another big numbers, it gonna greater than 2 to the greater than 2 to the 31. So it gonna cause overflow. But so that's why we need to read the question like carefully. Like there's like something like constraint whatever right there, right? So it give you the hint. But it's just like more safe way to write like this. So just keep in mind. Okay. So in this example, so we want to find the first and last. So how we do this? So if we find the midpoint in this example, right? If we found the midpoint, which is this one, right? That was mid. So A, if you found the A, you wanna find the leftmost, right? So leftmost, you wanna keep going, right? Until you found this one. This is the first position. So if the target, if the target is greater than equal than the number of the mid right there, right? So you wanna keep going all the way to the right until you find this one. right? So this is the last position, right? So all right, this is like kind of like basic idea. So I'm gonna use like two binary search. One is for the left half, another is for the right half. So let's code it up. So first, create the res array int new int, because it's it's only like you care about like the first and last position, right? So the size is gonna be 2, right? So corner case if nums equal to num, or nums the length equal to 0, you're gonna return new int. And then we have the rest 0 equal to find first, and parameter int target, and left equal to 0 and right equals to nums the length -1. Okay, so you have like left, you have right, and same as this. Okay, so after this we're gonna return res. So let's write the helper function. So int find first. We want to find the first one, so on the left side, left half side, right? So nums, so int nums int targets int left int right. So while loop, so left plus 1 small right, so int mid equal to left plus right minus left divided by 2. So if mid, so let me see, if mid, it's if numbers of mid, right, if numbers of mid is greater than equal than targets, so greater than equal than targets, then we we set the, because it means targets on the left side of the mid, right? So we're gonna set the right equal to mid, so, right? So this like it means target if satisfy, we have targets on the left half. So else it's gonna be on the right half, right? So we're gonna be like left equal to mid. So and then after a while we need to check at the end, because binary search is like cutting half merge, right? At the end we have like we have to jump up the while we have the left and right, we have to check both, because the way I write it's left plus 1 smaller than right, so that's why I need to check the 2 condition. So but I need to check the left first, because it's on the left half. You want to find the first position, so you're going to check the left first. If left satisfied, you return left, and then you go to check, and then you check the right. Nums of left targets, gonna return left. So if numbers of the right equal to targets, we're gonna returns right. So else we're gonna if not both cannot satisfy, it means we not found the answer, return the -1. So private int find last. Same, left plus 1 more than right, and we have like intermediate equal to left plus right minus left divided by 2, and if nums of the mid smaller than equal than targets, right? So it means on the right side, the right half side, which means if satisfy by we have targets on the right half. So why we need to have like the smaller and equal than? Because if we found the answer, it's a mid, right? For example, if we found a mid, it's a target, but we want to keep checking on the all the way to the rightmost. That's why you have to write less and equal than target, same as here, right? If you have mid equal to target, but you want to go to all the way to the leftmost because you want to find the first position. That's why. So it's like regular. If you write this, you're gonna write like something like it. Oh, somebody gonna write this, right? Mid equal to targets, and then you return mid, and then you do the greater and less and greater than target. This is gonna give you the wrong answer because you find the mid, and then you return, but it's gonna contain the duplicate. So you wanna keep checking all the way to the back. So this is wrong, so you cannot write this kind of thing. Okay, then you're gonna set the left equal to mid, right? Else you're gonna set right equal to mid. So same checking. So right now we're gonna check in the right first because we wanna get the rightmost the answer first, right? So if this is equal to targets, you're gonna return the right. If nums of the left equal to targets, return left. So we're gonna return -1. Yes, I think that's it. That's the answer. Let's run the code. Oh, there was something wrong. Let me see. Okay, let me check. Is there anything I did wrong? Press 1, press 2. Find first. Oh, I called the name wrong. The method name. This find the last. Okay, let's run the code. Okay, submit. Okay, great. So the runtime gonna be log n, right? We do the one binary search right there, and then this is another one binary search. You're gonna do log n, but it's still gonna be log n. But we create the space, constant space, only size 2. So we generally it's just a 1 space. So the time complexity is a log n, and then the space is 01, right? All right, thank you guys.